Hello everyone. In today's lesson, we are going to see how to use interpolation in the calculation of occurrence. The calculation of occurrence of a curve. The occurrence of the curve y is equal to fx from a to b is given by this formula. That the length is equal to the integral from a to b, 1 plus dy dx squared, then dx. So this is the formula we use when we are looking for the occurrence of a function from a to b. So we are going to prove how this formula came about. See, proof. Let's consider the graph of a function fx which goes like this from a to b. The lower limit is a and the upper limit is b. So we are going to see the formula you can use when you are looking for the occurrence from a to b. We are going to consider a small occurrence within this interval from a to b. Here I wanted to make a right angle triangle. Let us consider that this one is the dx, this one is the dy, and this one is the small arc at the arrow. As you can see here, we made a right angle triangle where the arrow squared is equal to dx squared plus dy squared. This is the Pythagoras Theorem. So the arrow is equal to the square root of dx bracket squared plus dy bracket squared. So the arrow is equal to the square root of, let's take dx bracket squared out of the bracket, 1 plus the y bracket squared over dx bracket squared. So the square root of dx bracket squared is dx, so the arrow will be equal to the square root of 1 plus dy over dx bracket squared times dx. So this occurrence is for a small part within the interval from a to b. So to have the interlength from a to b, we are going to take the summation of all the small arcs within the interval. So the summation here we're talking about is the interpolation. So that's why I'm going to apply integral from a to b on both sides. So we have the integral from a to b. So the integral of the arrow is the arrow, which is the occurrence of a function from a to b, is equal to the integral from a to b. So the square root of 1 plus dy over dx bracket squared. So basically this is the formula we use when we are looking for the occurrence of a function from a to b. This is how the formula came about. Let's do an example. Find the occurrence of a line whose slope is -2, given that the line extends from 1 up to 5. So we have the length which is equal to the integral from 1 to 5, then the square root of 1 plus dy dx here is this value, which is -2. So we put here -2 squared, then dx. So arrow is equal to the integral from 1 to 5, then 1 plus 4, then dx. So arrow is equal to the integral from 1 to 5, then square root of 5, then dx, which is equal to square root of 5, then the integral of dx is x from 1 up to 5, so the length will be equal to square root of 5, then 5 minus 1, so the length will be equal to 4, the square root of 5, then we put here unit of length. Unit of length. So this will be the length of that straight line from 1 to 5. So example number 2. Use integration to prove that the circumference of a circle is 2 pi times r. We are going to do it. We are going to consider the equation of a circle centered to 0, 0. As you all know, the equation is x squared plus y squared is equal to r squared. We'll make y the subject of the formula. Y is equal to r squared minus x squared under the square root. As you can see, we have a circle centered to 0, 0. We have a circle centered to 0, 0. This is x, this is y. We have negative r, we have r. We are going to consider a half of a circle, the circumference over 2, which means c over 2 is equal to the integral from negative r up to r, then 1 plus dy over dx squared, then dx. The circumference over 2 is equal to the integral from negative r to r, then 1 plus dy over dx bracket squared, then dx. So as you all know, y is equal to r squared minus x squared. So I need dy dx. So dy dx is equal to negative 2x over 2 square root of r squared minus x squared. I can simplify this and this. So dy dx is equal to negative x over r squared minus x squared, then under the square root. So c over 2 is equal to the integral from negative r up to r, then 1 plus negative x over r squared minus x squared under the square root, then squared, then dx. C over 2 is equal to integral from negative r up to r, then 1 plus x squared over r squared minus x squared, then under the square root, then dx. So c over 2 is equal to integral from negative r to r, then LCM here under the root will give us r squared minus x squared plus x squared over r squared minus x squared, then dx. C over 2 will be equal to integral from negative r to r, then r squared over r minus x squared, then under the square root, then dx. This is the same as having the integral from negative r to r, then r dx over r squared minus x squared, then under the square root. I took the square root of r squared, which is equal to r, and the square root comes here on the denominator. So that's why you see negative r to r, then r dx over r squared minus x squared. So we are going to Continue. C over 2 is equal to r, then the integral from negative r up to r, then dx over r squared minus x squared under the square root. We have c over 2 is equal to the integral from negative r up to r, there is r, then dx over r squared minus x squared under the square root. This is the same as writing the r integral from negative r to r, then dx over r squared 1 minus x squared over r squared. C over 2 is the same as having r, the integral from negative r to r, then dx over r square root of 1 minus x over r squared. We can simplify this and this. C over 2 will be equal to integral from negative r to r, then dx over 1 minus x over r squared. Let's change variables. Let's change variables. X over r to be equal to sin theta. So x is equal to r sin theta. So dx is equal to r cos theta d theta. X is equal to r sin theta, which means that dx is equal to r cos theta d theta. So our integration will become c over 2 is equal to the integral from negative r up to r, then r cos theta d theta over 1 minus sin theta squared. Let's change also the limit of integration in terms of theta. So when x is equal to negative r, which is the lower limit of integration, it means that negative r over r is equal to sin theta. So theta is equal to negative pi over 2. And when x is equal to r, which is the upper limit of integration, it means that 1 is equal to sin theta, and theta is equal to pi over 2. So c over 2 will be r integral from negative pi over 2 to pi over 2, then d theta. So c over 2 is equal to r then theta from negative pi over 2 to pi over 2. So c over 2 is equal to r then pi over 2 minus pi over 2. So c over 2 is equal to r times pi. C is equal to 2 pi r. C is equal to 2 pi r, which is the circumference of a circle that we all know. So as required.